Are you looking for a free CAD software for your DIY projects? Well, don't look any further. FreeCAD has got you covered. As the name suggests, FreeCAD is totally free of cost and an open source software. You will not have to sign up anywhere to download the software, and there is no subscription fee at all. Just like the old days, you install the software and you do whatever you want to do whenever you want to do. So let's get on freecad.org/downloads and download your version of FreeCAD 1.0 for your computer. Welcome back. So far in two videos we have discussed how to build this model. First we built two sketches on XY and XZ on top and front plane. We used the common area between those two extrudes, and then we applied some dress up features, and that gives us our final object. So this video, what I am planning to do is to show how to build this technical drawing from the model that we just built. So first we use the technical drawing to build this model. Now what if you build the model, you came up with this model and then you wanted to document that specification in a document. So that's what we will be doing. FreeCAD comes with the TechDraw workbench installed in it, and that's what we will be using to build our technical drawing. The first two buttons in the TechDraw, first one it says insert default page, and the second one says insert a page using template. So it looks like we need a page nevertheless because the other buttons are grayed out. So let's start with insert a page using template. So these are all the templates that comes with default FreeCAD installation, and those are saved in this location at your computer. So once you select your template, you can open it, and then that will open up the page that we will be building our technical drawing on. We will jump into building this model. The first thing we'll have to do is insert view. So there is this button on the toolbar, the sixth button from the left. It says insert a view. So without selecting the model, without selecting this model, if you click on there, it will give you the chance to import an SVG, a vector image, into your technical drawing. Say I wanted to bring in my logo in there, so I can navigate to my logo folder, bring in my logo in here. We can do that. We can bring in additional image vector images in there. We can do that. So how can we bring in this model in our technical drawing? We can select it and get into page and then hit image. Oh, it didn't work because it is still giving me a chance to import an external image to the environment, but we don't want, we want this model to be in there. So I select it, I go to page, this one becomes deselected, and that's why it is not bringing in that image here. The trick is, so the left panel does not work very greatly in this scenario. What I want you to do is select this model, this chamfer, the last in the progression, and then look at the bottom of the window. There is first model video. That's the file name that we are working on. That's the one. And then right next there is a page. So this is the page that shows up at the bottom of this screen. What I want you to do is rename that page. Say first model TechDraw, right? As soon as I rename it, this one also gets renamed at the bottom of the screen. So that means that's the one, the same thing. So what I want you to do is go over to the chamfer, select this model, and then not from the left panel, the tree view, go to the bottom of the screen, and from here select the second tab and then hit insert and give it a second. If it is a complex model, it will take a second to show up, but without seeing anything, I would not click in it. All right, there it is. So we have our front view. Now we can go over there. So this is the front in the model, and that's what is showing up as the front, right? So the front view is showing up here. That will be the center of our technical view. Now if you wanted to have anything else, for example, I want to have the plan view at the center, not the front view. What I can do is I can go click on this arrow from the part view. That will cycle through different views. So go up and down, it will switch between top, bottom, front, and back. So now I have the top view. So we can see the fillets in there. We can see the chamfer in there. So that's the top view, right? And then I want to add in this view group, I want to add, say, front view at the top. So I click on here on the secondary projections. It pulls in the front view. It says bottom. It's not that much important right now what it says over there, but the front view shows up. We can see that from looking at those front two screw holes. And if you wanted to have a side view in there, you can select one of the right or left side buttons from the secondary projection as well, and that will give you a side view in there. Now out of these three views, if I drag on the bottom, it will go up and down. If I drag on the left, it will go left and right, but it won't, the left one will not go up and down, the bottom one will not go left and right. To relocate the whole object, you can grab on the center one, the first view that we added. You can drag and then move it around. So that one is the center used to drag and around, like move around the whole thing, right? You can also select different scales here. It is automatic, so whatever you have will be compressed into one page. But if you wanted to go custom scale, you can do that as well. And these two spacing, X and Y spacing, they actually control the default gap between these two views. I'll go ahead and make it 10 for demonstration, and then you'll see that they are moving around. All right, so hit apply and OK. And that one, so now it is moving around. That 10 millimeter gap is corrected once you get out of that window. So because we said it is automatic, now things are automatically getting corrected because it's concising in there. So it's not one-to-one scale anymore. All right, so because it's a complex model, it's taking a second to actually compute everything. And someone say, be patient with this model when you are working in the TechDraw. So we have all the views in there. Now let's talk about the cross-section view. See, at this vertical face, we can see that there is a chamfer in there, there is a fillet in there, but we actually cannot see them, right? Because we know that those are there, but none of these views are expressing that thought. So a cross section helps you understand to go through in the middle and then what's going on in there. So what I want to do, I want to draw a cross section in here in the Y direction. So this direction, up and down. So select the front view, and then come over here on the toolbar. It says insert a simple or complex cross section view. Today we will only be working on the simple section view, right? So I select it on that. Now in here, before we do anything else, we will have to pick one of these four options. Because we said we will go vertical face, we will go up and down. I'm going to select one of this one or this one. So let's try this. After you select one of these four options, go all the way to the down to the window and then say live update, right? And then it will show me the update. It is stacked into there in the middle. I can drag and move it around somewhere here, maybe somewhere here, right? And that one actually shows me the cross section that goes through the middle of the body in the short direction, like in the shorter dimension, not the longitudinal direction. And now I can say identifier A, that means it will be cross section AA, and then that will reflect it in this view. So it looks fine to me, but if you wanted to rotate this view around, you'll have to do it later on. Just keep that in your mind if sometimes you want to rotate this around, and we can do that as well. All right, and what else? Maybe we want to do a longitudinal cross sections too. So hit OK, get out of that, and then do one more section view. Oh, we'll have to select a view first. So on the front, right? And we want to do another cross section. This time we will go lengthwise, right? And then hit live update. So this one is important to look at. So this is the cross section that we got, right? We want to place it right over there. Now it looks flipped in the vertical direction because that's not how our object looks like. So if we want to correct that, if we selected this, now we want to select this one. See if that changes anything. That changes anything, right? So that's how we correct the direction. Now that direction is right there. It's kind of like congested in here, so we may have to move things around just a little bit later on, but I'm going to go ahead and make this one BB section, right? And when we were working on our second video, we saw that having this line in this middle through these two smaller circular holes helped us determine this profile of this counter bore hole on both sides. So I'm going to keep them in there. But if you wanted to have this cross section go through somewhere else, say through this center of these big circles, you can do that coming in here. So if you update the Y section, so now it is at 20. If we want to go over there, if we knew the coordinate of this center, we could fit it in there, and that would draw the cross section through the big circular holes. We could do that, but I'm not going to do that. That option is there for you to consider. All right, so we have all of our cross sections that we wanted. We have this view section group, and now what I want to do, I want to move this object just a little bit on the right. Remember, it was 15 and we made it 10, and then it moves on the left side. We want to reverse that action. So select that view on the data panel, and here it says, actually we want to go to the project group, and here on when it says spacing X is 10, we want to make it 20. It moved over 10 millimeter on the other side. And so that's because we did it through the project group, because this view belongs to the project group, right? How about this one? How can we move it over on the side? We can actually drag and drop it over there, and that works too. And then I have another open portion right here, and maybe I want to put in the three-dimensional figure in there too. So let's see, let me align this just like that, right? And keep it selected, right? And go to the model. At this time, we don't want to do the insert a view. We want to do the active view, the three-dimensional view. And I can also crop it, but since I selected it, but know that I'll have to update this value later on. There. So there is my three-dimensional object. It can be also placed in my technical drawing. Sometimes having the three-dimensional object in there helps as well. So this one, now when I said cropping, looks like it's a little wider than what I need. It doesn't hurt, but if you wanted to correct those, on here in the image under the data panel, on the width when it says 128, maybe give it 85, right? And doesn't hurt. We can actually change the size of this image individually irrespective of the technical drawing part of this here. So we can say scale type custom, right? And then when it says custom, and then where it is 1, let's try 1.5, and that kind of zooms it just to make it a little bit bigger. Now we'll have to update our cropping values. On the height, it is cutting down, so maybe 150, right? Yes, there is that. So now we have constructed our technical drawing, And if you click on this button where it says turn view frames on and off, if you click on that, if you turn it on, this is the final view that we will be looking at when we export this technical drawing, right? No dimensions. We are gonna talk about that, the dimensions, in a minute, but the additional vertexes right here, it helps us fixing the dimensions up there. They won't be showing up in the final drawing. However, these lines are showing up. So I did talk about that just a little bit in one of my videos when we were working on this plane. This line, this line, this, and this line, all these four on the left and four on the right, I don't think they should be there. If we are not differentiating between two different planes, there should not be a line that shows up, right? So right here, this line, for example, this edge represents that the face right here and this face right here, there is a difference in elevation between these two faces, and that's what this edge represents. There is no elevation, like there is no jump in elevation between these two faces. There is a curve there, I know, but that's not how we want to see in the technical drawing. The curves are represented there. That's not how to do it. So I want to hide these lines. There is not a better way. I'm sure FreeCAD folks are working on it until that has been resolved, right? What I want to do is I want to select all the lines. So I selected all of these, and there is a button, it says change appearance of lines on the toolbar. Select on that, and on the color, maybe I say no color, like white, right? I wish there was a no color thing, but white works as well too. All right, so that's one way to hide unwanted lines. So this cross-section view, I think that's appropriate to have all those lines, but on this front view, they also have like 2 or 3 unwanted lines in there. All right, so you can now do that. You can hide unwanted lines. It's a workaround again. Maybe better days are coming on that part. Now let's talk about the most important part of a technical drawing, dimensions, right? So here we have the dimension, but know that it doesn't work with the keyboard dimension shortcut D like it worked in sketching. So this dimension doesn't work with D. You'll have to press it. So once you have this activated, right, come over, select an edge. It will give you an appropriate dimension. If you don't think this should be labeled as radius 25, you want that as 50 diameter, you can select the edge, go underneath the dimension, and then select insert diameter dimension. Say I know that this was 200 millimeters. Yep, that shows up as 200 millimeters. All right, so having too many views in there kind of like becomes challenging to work sometimes. I know that this was 207. Ooh, it's showing up 205. Maybe I missed it somewhere. Because that is the edge of the fillet. That's not what we are supposed to select. We are taking the inside, the actual hole. So that is 207 there. So yes, if you have fillets and chamfers in your model, we'll have to be careful about which edge we are picking. For example, here, I don't want to pick the outside because that's not representative of the hole that goes through. And then you can select one edge, or like, if you wanted to have the distance between the height of this overall object was 32, I believe. So select these 2 points by using Control key, and then while they're selected, hit dimension, and that will give you the distance between those two. So you can activate it and then select on edges, or select the edges and then go over, click on there too. Either way is fine. And so that's the dimensioning. I will let you finish up this document on your end as a practice. So I'm not doing any more dimensioning on this, but you know how to do it. That's the point. One thing that I haven't talked about is in the cross-section view. It has some patterns in there, and some of them are like blank or white spaces. And how, if you, this is the first time you're coming across a cross section, know that that's how it's supposed to be. The pattern, the hatched part, means those are solid material in there. So this is the line, that's the line, the BB line it is representing. So at some point it goes through the group that we built that I cannot see in here, and then goes through a solid material and then gets into this empty space created by this cylindrical hole. So those are the representation that goes through this cross section. So if you see empty space, know that that's an empty material. There's like no material, that's a void. I mentioned just a minute ago about not having those underneath the invisible features being displayed on this cross section. We can have different kind of lines representing our hidden features. So what I want to do, I want to select this object, this view, under the data tab, and under HLR parameters, come to hidden, hard hidden option, and then make it true. So now it shows up the hidden screw holes that we built and the hidden group that we built in there. And that is important. We want it on this one. Let's try that on this view, see how it appears. So we select that view, go under HLR parameters and hard hidden false, make that true, and there it is, it shows up. Look how many hidden lines are there. We don't want all of those lines. That actually makes it too busy to look at, and that sometimes it loses its purpose. So for this cross section, right, for this front view, I don't think the hidden lines are the best thing. So what I want to do, I don't want to do that in there, right? So hidden lines has their places. They are sometimes very important, sometimes you don't need them. Customization of these dimension annotations. So say 200, right? There is the center, it shows the center outside of the page. It looks really odd. For example, for the 200, this 207, we don't want that line to be drawn all the way up there. Select those dimensions that you don't want to be detailed drawn, and then go to view, and over here it says rendering extent, it says normal, we want to say minimal, and that kind of like makes it minimum. We can also do that, for example, on these dimensions as well. Let's try this one, right? And select those two and go to rendering extent minimal, and that kind of minimizes the arrow that we just drew. The same idea can be applied on other types of dimensions as well, where you see it fit. Say on this length, I am going to show you another example. Say I want to show the distance between this center and this center. So I selected the circular, the center of those circles, right? And then I activated the dimension tool. It shows up, say, somewhere here. You see how these two reference lines is actually going into the odd. It looks odd, right? And what if I wanted to shorten those two lines? The same thing. We want to select that and come here and it says gap factor ISO. It says 50. You can actually change those value from the preferences. The default value, I set it up as 50. It works fine. But for this specific one, let's say I want to make it 400. And that kind of, so the distance between this point and this point, it's measuring as 400, right? And the more you make it, say 500, the longer gap that it makes between the point and the reference. So sometimes that helps too. Those are the basic tips and tricks that I use to create my technical drawing. And once I'm done, all of this is done. What I do is I turn off the dots and see how it looks. If it looks all right, I can export that as an SVG. So if I export that as an SVG and then I can open it up in Inkscape, I want to do, if I want to do further modifications to it, I can do that. Or I just like save it as a JPG, a PNG image file. Or you can take the whole file and then export that as SVG, or there are like multiple other formats in there. You can export this as a direct PDF. You can do that too. So you can actually take this technical drawing, print it out, and then send it to someone else. They will be able to recreate your model. All right, so that's the technical drawing initial setups and preparing the drawing, and then also exporting that to use it. So that concludes the technical drawing part of this video. Now I want to talk about the different design philosophy, how we can do the same model in different ways. I'm going to go ahead and delete this technical drawing. So we talked about technical drawing, and then I think we are at a good place. And then we have this base block that we built over 2 days, and I want to delete it, go back. So all of these after the boolean, this will be the same for all the alternatives. So I'm going to go ahead and delete those, right? Because if those are remaining the same, those doesn't need to be talked in the alternatives. I want to delete this boolean. If you remember the thing where we combined these two extrudes, I want to delete that, and so we don't need that base block anymore. So these are the two products that we had from our first two sketches. So this was the one of the sketch, and this was another sketch. In the popular method in part design, it's not to common them. It's not to find out the intersection of it. It's not the popular idea. The popular idea is to cut things out. So what I mean by that is, let's say I create a new document in the part design. I create a new body. And I'm going to go ahead and so building this sketch is the same hurdle. When I'm copying it, so I select these two, Control C works. I don't want these planes there, right? So if you have this auto selected dependent object, deselect it. That way you can only choose what you need. And hit OK. So that's copied. Come over here, Control B, paste it. So we can actually reuse different sketches. We can do that. It's easy. So we have it. Now the popular method in part design, popular work philosophy in part design is to actually build things out one upon each other and then cut things away, and then that would be at the end it will be one final object, right? In our video, what we did, we built two bodies and put them together as a common. Let's talk differently. So what I want to do, I want to take these two sketches, put this into the body there. So now they belong to the body. And here I will start with the XY. I will pad it up just like previously. I want to go say 2 dimensions, right? It doesn't hurt. And then I want to go up by 70, go down by 10 or 5. I think we did 5, so we'll keep it at 5. So that's my first. And then, as I mentioned earlier, because it is the same model, if I do anything on this model within the same body, it will be added and subtracted by default. I can cut this part out, this extra part, this middle extra part, we can cut this out to make that middle body. So previously we built this sketch to contain this much area, to keep this much area. Now we are saying that will be saved anyway. We just want to delete this extra part. So we'll have to modify our thinking on the sketching. Let's make this one construction geometry. Remember, if you make a line construction geometry, it will not show up in the final sketch. Now we have these two lines, the boundaries. If I can close this shape up and close this shape up, we can use that to cut things away. So what I'm going to do, I'm going to take this polyline and make it like a closed wire. That's what the technical term is there. And I think it came down 5 millimeters. So I'm going to make this one, the lower part, make sure it doesn't matter. It can go more than that. As long as it's more than 5 millimeters, we are fine. So we'll just make it bigger. Oh, That's another thing. You can leave a sketch under constraint. You can leave it. Just don't make it over constrained. As long as it's under constraint, it still can work. It's a little wobbly, but it still works. So we have this face, right? And if this sketch, make a pocket, and it started to cut things away, but we'll have to go all the way up and all the way down. It doesn't matter whatever material you have, you'll have to go all the way through it. And there is an option for it. It says through all. So it took it all the way through all, but it didn't take it on the backward side. And so what we will have to do is we'll have to say symmetric to the plane. So if the sketch axis was right here, now it is going through all on the front side and on the back side. There. So we hit OK. So that's the popular method to work in part design. You make the big block and then you cut things away in the same body. Now we have half of the object, so we can make this cutting operation on the other side too. So what I'll do, this pocket represents that cutting operation. Although you selected the whole thing, the pad and pocket all together is the body, right? But the pocket itself on this tree represents only this cutting operation. So we will replicate that cutting operation on the other side. So we select the pocket and then mirror it over on the other side, right? Now by default it is taking the vertical axis, works for us. We hit OK. See, so we are using the same sketch, same two sketches, but different work philosophy, and we have our model. The noticeable difference between this model and this model is, now I still, although we kind of like combine these two sketches, I can have access to that sketch, the original sketch. I can do that. But in the common method, when we put this together as a common, those sketches, it seemed to me I cannot access those sketches anymore. So that's the downside of having this common thing, right? There it is. So, and then we go about our day regularly. We make the whole, we can apply dress up features, but the rest of them are same, but this is the different philosophy. Also, I want to take a couple more minutes to talk about part workbench. What if you wanted to do the same thing in part? In part workbench, there is no obligation to have everything within the same body. Part, you can have it itself is a part, so the body having everything within the same container, it's not obligated here. I can copy this. I don't need the XY plane. Also in part workbench, you don't need to worry about that plane there. Let's open up a new file, and in the part workbench I paste this just in there, right? And now I can, in part workbench, I can extrude that by itself, like without having it under the container. And then in the part, right, we'll have to cut things away following the same idea, but it will not cut it by default. So we'll have to make it 80 and 80 and apply just like that. But it is not cutting things away. There is no cut button in here. You just build parts and then do the cutting, the Boolean operations by yourself. So what I'm going to do in the part, it makes more sense to mirror it over right now. So I'm just going to mirror it against the YZ plane, right? And then, although again I said these are mirrored, they are not fusion together. So what I'm going to do, I'm going to fusion them together using this button here. It says union, right? And that's my fusion. Now I can take the underneath body, right? I can take this one and delete this much of a portion from there to make our main body. So what I want to do, I want to select that one first, the one that I want to keep, and the one that I want to delete, select it as a second, and then hit cut. Yeah, so that's part workbench, no body obligation, do all the Boolean operation manually. It has its upside and downside too. So, and then part design, you do the cut operation, the like by pocket, and also the first one that where you have the common operation. So these are the different philosophies depending on which model you are working on. It comes in handy to know all the alternatives in model building. Well, folks, it's already a long video, so I'll leave it up there. If you have any question, comment, suggestion, let me know in the comment section below. Also, there is a forum on FreeCAD. You can let your specific questions know, and then people will help you. I hope you enjoyed the journey. I welcome you into the FreeCAD community, and thank you for watching. I'll see you in one of my next videos then.